You stand in the doorway of a dim stone dairy, wooden pail heavy in your hands, steam curling off the surface of milk you pulled from the udder only moments ago. Already the flies are circling, drawn by the sweetness and the warmth, and you feel the morning sun climbing steadily toward its merciless noon position. Heat and time are working against you now, invisible forces that could turn this precious liquid into a stomach-churning disaster before the day is through, and you cannot afford to waste a single drop of something your family needs to survive the weeks ahead. The children are thin after a hard winter, the goat barely recovered from a difficult birth, and every calorie matters in ways that people with supermarkets and corner shops cannot easily imagine. How did people drink milk for thousands of years before refrigeration existed, and why didn't they spend their lives doubled over in agony from spoiled dairy? The surprising answer is that the safest way to store milk was often to stop it being milk at all, to transform it, quickly and deliberately, into something that hostile microbes could not easily claim as their own. To understand the urgency, you need to appreciate what milk actually is from a biological perspective, and why its virtues are inseparable from its dangers. Fresh from the animal, it arrives as one of the most nutritionally complete substances in nature. Sugars, proteins, fats, minerals, and moisture, all suspended in perfect balance, designed by millions of years of evolution to support the rapid growth of vulnerable offspring. But here's the trap. Everything that makes milk valuable to you also makes it irresistible to bacteria, yeasts, and molds that have been evolving just as long to exploit exactly this kind of resource. In warm conditions, bacterial populations can double every 20 minutes, which means a single contaminating cell can become millions within half a day, turning the pail into a seething biological reactor. The same creamy richness that feeds an infant can become a breeding ground for pathogens that cause violent illness. And in an era without antibiotics or intravenous fluids, or even clean water for rehydration, a bout of severe food poisoning could kill particularly the young, the elderly, and anyone already weakened by other stresses. People who handled milk understood this danger viscerally, even if they could not see the microscopic world responsible for it or explain the mechanisms. They watched batches turn foul in the heat of summer afternoons. They buried children who sickened after drinking milk that smelled just slightly off. They learned, through generations of painful trial and brutal error, that speed was not optional. You either processed that milk immediately, or you gambled with the lives of everyone who would consume it. The genius of traditional dairy preservation lies in a counterintuitive principle that might seem backwards to modern sensibilities. Sometimes, the best defense against dangerous rot is to encourage a gentler kind of spoilage first. When you allow certain beneficial microorganisms to colonize fresh milk before harmful ones can establish themselves, you are essentially staging a territorial war and picking the side you want to win. Lactic acid bacteria, present naturally in the environment and on the surfaces of clean equipment, convert milk sugars into acids that drop the pH of the liquid toward levels that many dangerous pathogens struggle to tolerate. As acidity rises, conditions become increasingly hostile to organisms that cause severe gastrointestinal illness in humans. This is not sterilization. The milk is still teeming with life. Still a complex biological community, but it is competitive exclusion, a crowded battlefield where the microbes you want are outcompeting and outpacing the ones that could hurt you. Fermented dairy products, like yogurt, soured milk, kefir, and cultured buttermilk, emerged across virtually every pastoral culture on Earth, not because people understood microbiology, but because they understood results and passed down what worked. The batches that turned sour in a controlled way kept longer, tasted acceptable or even desirable, and made fewer people sick. The batches that simply rotted in the heat were disasters that everyone learned to fear and discard. Over centuries, communities refined techniques to tip the odds consistently, learning through careful observation which vessels, which temperatures, which starter additions, and which timings yielded the safest and most reliable outcomes across different seasons. But fermentation was only one weapon in a much larger arsenal, and different regions developed different solutions depending on their climates, their animals, and the length of time they needed their dairy to last before consumption. Cheese represented one of the most sophisticated transformations available to traditional dairy makers. By adding rennet extracted from the stomachs of young ruminants, or plant-derived coagulants used in some Mediterranean and Middle Eastern traditions, people could separate the solid curds from the liquid whey, concentrating the proteins and fats into a denser form while draining away much of the moisture that bacteria need to thrive. Salt pressed into the curds drew out additional water and created an environment inhospitable to many spoilage organisms, buying further weeks or months against decay. Aged cheeses, left to mature in cool caves or deep cellars for months or even years, developed complex rinds and internal microbial ecosystems that further protected the interior from dangerous contamination while transforming flavor in ways that became culturally prized. The hard, dry wheels that resulted could survive journeys of hundreds of miles that would have destroyed fresh milk in hours, making cheese one of the most tradable and taxable commodities in many ancient economies. Butter offered another pathway, separating the fat from the water-based components of milk and removing the lactose sugars that harmful bacteria feed on most readily. Clarified butter, heated gently until the water evaporated and the milk solids were skimmed away, could last for months at room temperature in sealed containers, a staple across South Asia, the Middle East, and parts of Africa where the heat made other forms of preservation impractical. Whey, the thin liquid left behind after cheesemaking, was never wasted despite being considered less valuable than curds. Its natural acidity made it useful for preserving other foods, for drinking mixed with water, for cooking grains, or for feeding to pigs who would convert its remaining nutrients back into useful meat. The containers people used mattered far more than modern observers might initially expect, because vessels were not passive holders but active participants in the preservation process and in the invisible microbiology that determines success or failure. A wooden tub used repeatedly for fermenting milk would develop colonies of beneficial bacteria embedded deep in its porous surface, effectively becoming a living starter that inoculated each new batch with the right organisms before dangerous competitors could gain any foothold. This is why traditional dairy makers were often reluctant to scrub their equipment too thoroughly or replace old vessels with new ones. They understood instinctively that something in the wood itself made the next batch work better. Even if they had no vocabulary for microbial ecology, ceramic vessels varied dramatically in their properties depending on how they were made. Unglazed porous pottery allowed evaporation that cooled the contents through the same principle that makes sweating skin feel cold in a breeze, while glazed interiors could be cleaned more thoroughly between uses and prevented unwanted absorption of flavors. Animal skins, used by nomadic herders across the steppes of Central Asia and the grasslands of Eastern Africa, offered flexibility for transport and could be selected for specific tanning treatments that affected flavor and fermentation dynamics. Archaeological evidence from ancient pottery sites, lipid residues absorbed into the clay over millennia, now analyzed by modern chemists, reveals dairy processing extending back at least 9,000 years in some regions, with specific chemical markers distinguishing simple milk storage from deliberate fermentation and cheesemaking. The recurring theme is that people were not guessing randomly. They were inheriting vessels, techniques, and invisible microbial communities from their predecessors, refining systems that had been tested across countless generations and discarding approaches that failed. A grandmother's cheese mold, or her favorite fermenting crock, carried more than sentimental value. It carried the living biology that made her recipes work reliably. Temperature control, meanwhile, was pursued with ingenuity that anticipated the refrigerator's function without any of its mechanical parts. Spring houses, built carefully overflowing water from underground sources that emerged at constant cool temperatures year-round, could keep dairy products significantly colder than the ambient air, sometimes by 15 degrees or more, depending on the local climate. Deep cellars dug into hillsides or beneath houses reached below the frost line where the earth maintained steady temperatures, regardless of whether summer blazed above or winter winds howled across the landscape. In arid climates from the Mediterranean basin to the deserts of North Africa and the Middle East, porous clay pots exploited evaporative cooling with remarkable effectiveness, allowing water to seep slowly through the walls and carry heat away as it turned to vapor on the outer surface. Night cooling was another simple but effective technique practiced across many cultures. Processing milk in the evening hours when temperatures dropped, allowing products to rest through the coldest part of the night, and insulating them with straw or cloth to slow warming through the following day. None of these methods approached the efficiency of mechanical refrigeration, but in combination with fermentation, salting, and chemical transformation, they extended the window of safety enough to make a meaningful difference in outcomes. The gap between milk spoiling in 4 hours versus 12 hours could mean the difference between a usable product feeding a family and a complete loss requiring disposal. And when you consider that a single cow might produce several liters daily through her lactating season, or that a herd of goats multiplied those volumes considerably, the pressure to preserve every batch successfully was relentless and shaped the rhythm of daily life. Mobility added another layer of complexity to the challenge, because many of the world's great dairy traditions belonged to people who did not stay in one place and could not rely on permanent structures like cellars or spring houses. Nomadic and semi-nomadic herders across the vast Eurasian steppes, through the rugged mountains of the Caucasus, and across the savannas of eastern Africa needed dairy products that could survive travel on horseback, packed into carts, or strapped to the sides of camels crossing waterless distances measured in weeks. Fermented milk drinks, naturally soured and acidified to levels hostile to many pathogens, traveled far better than fresh milk and provided hydration along with nutrition in environments where water could be scarce or unsafe. Hard cheeses wrapped in cloth or wax, or packed in salt within sealed containers, could endure weeks of jostling and dramatic temperature swings that would have destroyed softer products within days. Butter churned in skin bags during the motion of the journey itself. The constant rocking of a horse agitating the cream inside represents an innovation that herders may have discovered accidentally when milk arrived at a destination, already separated into golden fat and thin buttermilk. Soldiers on campaign, merchants crossing trade routes, and pilgrims on long religious journeys all relied on preserved dairy as a compact source of calories and fat that would not spoil in the pack. The geography of dairy preservation was never about a single technique, but about matching the product precisely to the journey, the climate, and the expected duration before resupply. None of this should suggest that traditional preservation methods were foolproof, or that pre-modern people lived in some harmonious natural state that industrialization disrupted. Honesty requires acknowledging the gaps, the failures, and the deaths that occurred despite every precaution. People did get sick from dairy, sometimes seriously, sometimes fatally, despite generations of accumulated knowledge. Outbreaks could ripple through households when a batch went wrong, when contamination crept into a previously reliable system, or when an animal was unhealthy in ways that affected her milk before anyone noticed. Children and the elderly were always most vulnerable, their bodies less capable of fighting off pathogens that healthy adults might survive, with nothing worse than miserable days. Infant mortality in many pre-modern societies included deaths likely connected to tainted milk, though records rarely allow precise attribution. Tuberculosis and brucellosis could spread through milk from infected animals, a danger not understood until the late 19th century. The knowledge that protected communities was local, fragile, and easily lost when populations were displaced by war, or when experienced practitioners died before passing on their skills. Yet, despite these caveats, the cumulative evidence suggests that the preservation toolkit developed over millennia reduced the frequency and severity of milk-related illness enough to make dairy a viable and often essential part of human nutrition across much of the world. Return now to that doorway, the pail of warm milk growing warmer, the flies still circling and the sun still climbing. What looked like a simple choice, drink it or store it, use it or lose it, was never simple at all. Behind every swallow of fermented milk, every wedge of aged cheese that could travel for months, every spoonful of clarified fat spreading golden across flatbread, there lay a web of knowledge about biology, containers, climate, and inherited technique refined across countless generations by people who observed carefully and transmitted what worked. They were not ignorant rustics awaiting the refrigerator. They were practitioners of a science they could not name, winning daily battles against invisible enemies through methods encoded in routine, in vessel selection, in the timing of evening milking. Transformation was the key, turning fresh milk into something else, before hostile microbes could turn it into poison first. Speed, acidity, dryness, salt, fat separation, temperature management, and the careful husbandry of living vessels all played their roles in an intricate system passed from hand to hand. The refrigerator did not give humanity the ability to preserve dairy. It gave us a shortcut past all that complexity, a way to suspend the biological clock rather than outrace it. And standing in that doorway with your pail, flies circling, heat rising, you would have understood something we forget in our age of cold chains and expiration dates, that every glass of milk we pull from a humming appliance is the heir to a longer struggle, a quieter triumph, and a much harder-won peace with the invisible world that wants what we want and moves faster than we ever could.